So last time we did polar coordinates. Now we'll do area and arc length. Let's read the title. 시작. Area and arc length for polar curves and conic sections, parabola. So first of all, area of a region bounded by a polar curve. What is a polar curve? Polar curve is graph. Last time we have looked at how to graph a polar equation, right? Graph of a polar equation. Where did we draw the polar equation? On the plane, on XY plane. On XY plane. Okay. And when we draw the graph, f is continuous. So we assume that f is continuous. F is a continuous function. So here theta is from A to B, right? So we have a XY plane, XY. And what is theta equal to A? Last time, what was the curve? What was the graph of theta equal to A? What was it? When we had theta equal to pi over 4, what was it? It was a line, right? So this is a line, goes through where? Origin, right? Of angle A. So theta equal to A is a line where the angle is A. That's theta equal to A, right? And what's theta equal to B? It's again a line. So which is bigger? A is bigger or B is bigger? B is bigger, so B will be somewhere here. So that's B. Make sense? So theta equal to B is a line. So that's B. Theta equal to B. So between A and B, so between here and here, the angle is increasing. And according to each theta, we have corresponding radius r. R can be positive or negative. Suppose r is positive, then we'll have something like this, something like that, depending upon what r is. So as theta increases from A to B, we have some r. So this is the region. Make sense? Okay. So we want to find the area of this region. Okay. So what we'll do is, theta is from A to B, so we're going to cut so that the radial lines are from the pole. Okay. So we're going to cut this in equal angles. So cut this in equal angles like this. Okay, so let's take one subsection. Let's take one of these here. Okay, so let's look at this. So we're going to look at one typical subsection and then we'll add them up. The problem with this is the following. It looks like this. Is that right? And this angle is delta theta. But the problem is, for each theta, the radius is all changing. Right? So what we will do is, we're going to pick a sample r. So we can either choose the left angle, right angle, or a middle angle. And we'll choose one sample radius. Get it? So, if you recall calculus 1, if this is r equal to f of theta, then if we put theta and r, then we have a function. So theta is from A to B. And it is a function, r is a function of theta. So in calculus 1, you divided this into equal section, right? And you chose either left end point, right end point, or a middle point, and you took this sample height and you assumed that the rectangle has the same height throughout that subinterval. That's what you did, right? So we'll do the exact same thing. We'll choose either left angle, right angle, or a middle angle. So according to the middle angle, there is one particular radius, and we'll assume that that radius is constant throughout that subsection. Make sense? Okay. So here, we choose the middle angle here. So that is the radius at the middle angle, and we will assume that r is constant like this. Okay, so we're going to approximate the actual area by the area of this subsection. Get it? Okay, so this is r as some particular angle, theta I star. That is the sample angle. And it is the radius at that sample angle. Okay, so if we recall our geometry, what is the area of radius r? What's the area of a circle of radius r? Pi r squared. That is when the intersecting angle is 2 pi. Is that right? Okay. So here we are looking at subsection like this, where the angle is delta theta. So corresponding to that, we'll have an area. So what's the delta? What's the corresponding area when the intersecting angle is theta, delta theta, right? Then we can find delta A. What is delta A? Delta A is what? 1 over 2 r squared delta theta, right? Okay, so that is the area of one subsection. Now we'll have to add them up. So the area of the whole thing is, we'll add delta A. Delta A is 1/2 r. R is at a sample angle, delta theta, and then I1 to n, depending upon how many subsections that I have. And then how can I make this precise? Take the limit as n approaches to infinity. Look at more subsections, right? Then we can make it more precise. So this is the limit as n approaches to infinity. R squared. Yep. 1/2 r squared. Delta theta. Any question in this derivation? What is limit of the sum? Integral, Riemann integral, right? So this is equal to integral. Delta theta becomes d theta, right? So the variable of integration is theta. So theta is from where to where? A to B. So theta is from A to B. 1/2 is a constant, so that can be pulled outside. So 1 over 2, and then we get r as a function of theta squared. So this is the area of the region. bounded by polar curves. You will have to memorize this. So if you understand the derivation, it's easy to memorize. Any question? And I made a grammatical mistake here. What is my mistake? Find the grammatical mistake. And S, right? That's wrong. So please erase by polar curves. Any question? Okay, here we assumed that R is positive. But because of this R squared, because of this squared, right? Same thing is true when R is negative, when R is less than 0. So, here, note, 시작. This formula also applies to the region that have what? A negative loop, which is R less than 0 because of R squared. That is also true. The same formula is true whether R is positive or negative. Go ahead and do number 2. True or false? Okay, true or false? True or false? Important. Red region, yellow region, the area is the same. Is that true or false? What is the area? Integral A to B, what? F d theta. F is R, right? So this is integral A to B, R d theta. What's the area here? 1 over 2 integral A b R squared d theta. Are they the same? No, they are not the same. This is on xy plane, remember. What is x in terms of R and theta? X is R cosine theta. What's y? R sine theta. So to find the area, you should not look at this. Okay, you have to look at it on the xy plane. Get it? Yep. Let's read. 시작. Example find the area of the region bounded by inner loop of r equal to 1 plus 2 sine theta. So let's draw r and theta for our reference. So first of all, 2 sine theta is like this with the maximum and minimum 2 and minus 2, and it is translated up or down. Up by 1. So go ahead and draw. Is translated up by 1, right? So it must go through those points. Yeah. Right? Okay. So it is this. Where this is 1. This is what? 3. And this is what? Minus 1. Right? And we have to see where they are 0. Where they are 0. So let's do that. So when are they 0? 1 plus 2 sine theta must be 0. So theta is, sine theta should be minus 1/2. So, I don't know how you do this, but this is how I learned. All students take calculus. All students take calculus. 모든 학생은 미적분을 듣는다. So, all meaning everything is positive here. Which is positive? Sine. Only sine is positive. And maybe cosecant, 1 over sine. Here, only tangent or cotangent is positive. Here, only cosine or secant is positive. Okay? So sine is negative, so it should be on the 3rd or 4th quadrant. And what's the reference angle? Which angle gives you half? Sine half. Sine of which angle is half? (30도예요, 60도예요? Sine half. 30도, right? 30 degrees, which is what? Pi over 6. Exactly. Yeah, pi over 6. Yeah. So here the reference angle is pi over 6. Pi over 6. Pi over 6. Yeah. Okay. So what is this thing right here? It is pi. Pi is here. Okay, so what is this point? Right here and right there. This is 11 pi over 6. 2 pi minus pi over 6. How about this one right there? 7 pi over 6, yeah. Fine? Okay, so let's draw the polar curve. So at 0, it is 1. So at 0, it is 1. Yep, when angle is 0. When angle is pi over 2, what is it? 3, positive 3. So 3 here. When angle is pi, what is it? It is 1. Yeah. When angle is pi, it is positive 1. So it should be negative 1 on the xy plane. Is that right? And 0 to pi, they are symmetric. Yep. So, and and the radius here are bigger than 1. So, should I go this way or this way? Radius is bigger than 1, so it must go out like this, and then hit 3, and symmetrically come back to -1. That's from 0 to pi. And then for 7 pi and 11 pi over 6, so here to there, as we mentioned, it is this. Yep. And then over here, it is positive and it is 0 at 7 pi over 6. So it must be tangent at 7 pi over 6 like that. It must come to 0. And between 7 pi over 6 and 11 pi over 6, which loop do I have? Positive loop or negative loop? Negative loop of the height 1. So, negative loop. So actually my region is here, but it is negative loop. So I have to go inside by how far? By 1. By 1. And then loop, negative loop, right? And from 11 pi over 6 to 2 pi, it is again positive. So this thing is on here, and then it is positive to 2 pi. So it is going like this. From 11 pi over 6 to 2 pi, this is positive loop. Okay, so the final thing is the following. So it starts at 0, goes around, hit pi, hit 7 pi over 6, then it is negative loop, hit 1, 11 pi over 6, up to 2 pi it is positive loop. If you have done the homework, what is the name of this? If you have done the homework, what is the name of this? Lima-san, right? Lima-san. So in the homework I said this is what language? French. French. And what does it mean? Snail. Yeah, it means snail. What's snail? This is snail. Does this look like this? Right? So it is called snail. Lima-san. Okay, so let's find the area. What we have to do is find the area. Area of which loop? Inner loop. Inner loop is from where to where? Which angle to which angle? 7 pi over 6 to 11 pi over 6. But R is negative. Yep. Okay. So the area is 1/2 integral where to where? 7 pi over 6 to 11 pi over 6. What's R? R squared. What's R? 1 plus 2 sine theta squared and what? D theta. Fine? Okay. So since we have done calculus 1, we're all experts in integration. 7 pi over 6, 11 pi over 6. We get 1 plus 4 sine theta plus 4 sine squared theta d theta. Everyone agree? Okay. What's antiderivative of 1? Theta. What's antiderivative of 4 sine theta? Minus 4 cosine theta. How do we do sine squared? Change to what? 1 minus cosine 2 theta over 2. Yep. So is half 7 pi over 6, 11 pi over 6, 1 plus 4 sine theta plus 4, 1 minus cosine 2 theta over 2 d theta. So let me write the antiderivative and I'll leave everything else to you. Theta minus 4 cosine theta, and this is 2. So plus 2, fill in the blank, antiderivative of 1 minus cosine 2 theta. 시작! Theta minus sine 2 theta over 2. And we have to plug in 7 pi over 6 and 11 pi over 6. Okay? Calculation is yours. Any question? Okay, now how would we find area between two polar curves? What would you do? So we have xy, theta A, theta B, but there are R1, and there's R2. And you want the area of this region right here. What would you do? Tell me. Hot? Sure. So what would you do? You're going to take the area of the whole thing and then subtract the area of this thing, right? Makes a total sense. Yeah? So it is 1/2 integral A to B. Area of the whole thing is what? Area of the whole thing. R2 squared d theta. Area of the smaller thing is R1 squared d theta. So it will be R2 squared minus R1 squared d theta. If we put R2 minus R1 squared, am I right or wrong? Is this right or is that right? Are they the same? No, this is wrong, okay? It is R2 squared minus R1 squared. This is wrong. Okay, so keeping that in mind, go ahead and draw these two things. R equal to 1 plus sine theta and R equal to 1. Go ahead. 아까 그 스네어 그림은 제가 찍은 거예요. 그래서 이게 올려도 돼요. 야. What is the name of r equal to 1 plus sine theta? It's a cardioid. 1 plus sine theta, it looks like this, right? Where is it 0? 3 pi over 2. So it goes out tangent at the line, 3 pi over 2. And at 0, it is 1. At pi over 2 is 2. At pi, it is 1, so it is minus 1. 0 at 3 pi over 2, and it comes back to 1, right? So 1, 2, symmetric, comes back to 0, tangent, and goes out tangent, all positively. And what is r equal to 1? It's a circle of radius 1, right? So this is the circle. Right? Okay, so let's read the problem. 시작. Area between two polar curves. Find the area of the region inside of r equal to 1 plus sine theta and outside of r equal to 1. 1, 2, 3. Which region? 1, 2, 3. Which one? It is 1. Inside of this, outside of that. So it is 1, right? So it's the region right here. So it is from where to where? Angle is from where to where? 0 to pi, exactly. But do you see that it is symmetric? Yeah. So area is, we can do 1/2 0 to pi, or we can do 2 times 0 to pi over 2, right? What's outer radius? 1 plus sine theta squared. What's inner radius? 1 squared, and then we get d theta. You can do this, right? So let me skip the calculation. So that's how we find the area between two polar curves. Any question? Okay, so area is done. Now arc length. Arc length of a polar curve. Polar curve is again in xy. Where are you going? Come back quickly. No, you can go, but come back quickly. So, polar curve, again, it is on the xy plane. So if I draw this on theta r, I will get something. If I draw this on the xy plane, I'll get something, right? So, the length here to there, and the length here to there, which length am I talking about? Number 1, number 2. Number 2. Are they the same? They are not the same, okay? So we are not doing this, we're doing this, okay? Yeah. So, polar curve length, okay? So again, we're going to cut this like that. And let's take one subsection. So what we want is the length of this whole thing. What we want is that length. To do that, I'm going to cut the angle. and take one part. Let's look at this subpart. Let's look at this subpart right there. Then it looks like this. Is that right? So what we'll do is we'll look at left and right endpoint and then draw a right triangle. And we will approximate the length of this dark green with the length of the light green. Get it? Okay. Again, this is on XY plane. This is on XY plane, remember? So this is delta X and this is delta Y. And this length is what? Square root of that, right? Okay. So here, so we're going to call that delta L. Delta L is length of this is square root of delta X squared plus delta Y squared. Make sense? We're not done yet. But the problem is, these are given in terms of the polar equation. Right? Okay. So last time we did the relationship between r theta and x and y, right? What's x in terms of r and theta? R cosine theta. What's y? R sine theta. And what's r? What's r? F of theta. So actually, what is my independent variable? What determines everything? Theta determines everything. Exactly. So remember, x equal to r cosine theta, but r is a function of f. And y is r sine theta, and this is function of f, function of theta. R is function of theta. Is that right? Yeah? Okay, so what we'll do is come back here. Having x and y alone, that's not enough. I have to express x and y in terms of theta. So we will look at this. So this is equal to, square root of, let me introduce theta. What did I do? I divided by theta. So to undo it, what do I have to do? Multiply by delta theta squared. Did I change my expression? Did I change my original expression? No, I didn't. It's the exact same thing. Yep. Okay. Do you agree that I can put this into one fraction, delta x over delta theta quantity squared? Yep. So this is nothing but square root of delta x, delta theta squared plus delta y, delta theta quantity squared, and I'm going to put that outside of the square root. Theta is increasing from a to b, so delta theta is always positive. So what's square root of delta theta squared? Delta theta is usually absolute value, but we don't need absolute value because delta theta is positive. So we get delta theta. Agree? Okay. So the total length L is, we add delta L. Right? We have to add them up, and then to do better and better, we have to take the limit. We have to look at more subsections. So that is equal to, what is limit of the sum? Integral. When I do this limit, delta x, delta theta can be approximated by dx, d theta. This is dy, d theta. And this is d theta. So, is equal to integral square root of dx, d theta quantity squared plus dy, d theta quantity squared times d theta. Theta from where to where? A to B. Okay? Fine? But we can simplify this further because I know the exact formula of x and y. Okay? X is this. X is f of theta times cosine theta. Let's take the derivative. F is a function of theta, cosine is a function of theta. So to take the derivative, which rule do we have to use? Product rule. Okay? So let's do that. But remember, so over here on the side, right, dx, d theta is what? X is f times cosine. Let me suppress theta here to simplify. Okay, so let's take the derivative. Dx, d theta is what? F times derivative of cosine, which is derivative of cosine is minus sine plus f prime times cosine, right? Yes? It's the product rule. Y is f times sine. So what is dy, d theta? F cosine plus f prime sine. Is that right? But what we need are squares. So let's square this square. Then we get f squared sine squared plus f prime squared cosine squared plus minus 2f prime sine cosine. Is that right? Okay. So dy d theta squared. So let's square it. Then we get f squared cosine squared plus f prime squared sine squared plus 2f prime sine cosine. Yeah. When we add, what happens? What happens? When we add, what happens? This and that cancels out, right? Cancels out. And when I add this plus that, what do I get? F squared. Why? Sine squared plus cosine squared is 1. When I add this, what do I get? F prime squared. Right? Okay. Therefore, now this can be written as follows. Now this is equal to, right? According to this, by this integral a b square root, tell me, f squared theta plus f prime squared theta and d theta, that is the length. Okay, so memorize. on the derivation. So basically we cut the angles into equal subsections and we change it to delta x, delta y in terms of theta. Okay, so let's do an example. Again, what's length formula? 시작! Integral a to b square root of f theta squared plus f prime theta squared d theta, right? Find the length of the curve. So let's draw it on x and y. When theta is 0, what is my radius? 0, right? When theta is pi over 2, what is my radius? Pi over 2 quantity squared, which is about 1.5 squared, right? When theta is pi, what is my radius? Pi squared. So from 0, radius increases, hits pi over 2 squared, keep increasing and hit pi squared and stop there because theta ends at pi, right? If it go on, what will that be? Suppose it goes on forever, what will that be? It will be a spiral, S-P-I-R-A-L. 회오리처럼 이렇게 막 가는 거죠, right? Spiral, right? So this looks like this. So that is pi over 2 squared, and this is pi squared minus pi squared. Make sense? So this is spiral. So let's find the length. Before we find the length, where do we see this spiral? So this is the same snail that I took the picture of. Snail, French로 뭐라고요? Limaçon, okay? But if you look at the back side of it, this is the picture that I took. What do you see? Spiral. Interesting. Like this, yep. Yeah. So anyway, let's find the length. Okay. So 시작. L is what? 시작. Integral 0 pi square root of theta squared is what? This is f. This is f, yeah? So f squared plus f prime. What's f prime? 2 theta quantity squared d theta. Yes? Okay, is 0 to pi integral theta to the power 4 plus 4 theta squared d theta. Agree? Yeah. How do we integrate this? What do we take out? Theta squared outside of square root. Then we will get theta squared 4 d theta. Yep. What do we do now? Substitution. Exactly, substitution. Yeah. What's u? What's u? Theta squared plus 4. What's du? 2 theta. I have theta there, right? So we can create 2 to make it du, and to undo it, divide by 2. Then we get square root of u du form, right? So it's equal to 1/2. What is integral of u squared? U to the half. Integral u to the half du is u to the, this is u to the 3/2 over 3/2 is the same as multiplying by 2/3, and then we plug in 0 pi. Yep. One-third pi squared plus 4 3/2 minus 4 to the 3/2 is how much? 8. Yep. So this is the length. Any question? Okay, conic sections. 시작. Conic sections. Intersection of a plane and a double cone. What's cone? Cone looks like this. What's double cone? That's double cone. Okay? So, this is the cone, right? Upper part. And I'm going to cut it with a plane. 평면, right? Like that. Like this. Cut it. Cut. Then what kind of intersection do I get? I get some intersection that is called parabola. Cut it like this. Cut like that, then I get parabola. Suppose I cut it like this. Slide through. Then what will I get? I will get a circular thing. 타원. That's ellipse. Ellipse. If I cut exactly horizontal to the x or perpendicular to the axis of the cone, then I will get a circle. Is that right? So suppose there is another cone at the bottom. Imagine there's another cone at the bottom, and if I cut it through like that, then I will get one up there, one down here. That is called hyperbola. So by cutting a double cone in various ways, we can get parabola, ellipse. Ellipse includes circle. Hyperbola. By cut with a plane. Or by cutting like this, then we get ellipse. And when we cut like that, we get hyperbola. Okay? So among these, let's look at parabola first. Let's read. 시작. Parabola of parabola is the set of all points P in a blank that are blank from a fixed line directrix and a fixed point focus not on the line. So to make a parabola, how many things are needed? Two. What and what? Point and a line. But the point should not be on the line. Okay? Line is called what? Directrix. And the point is called what? Focus. Two things are fixed. A parabola is the set of points P in a plane. Okay, so parabola is on a plane. Why is it on a plane? We cut the cone with a plane, so the intersection will be on the plane. So plane has x and y coordinates. X, y. Fine? So parabola is on a plane, okay? So let me choose a directrix, a line. Let me say green is my directrix. And I need a point not on the line. So let me choose my focus as this point right here. That's my focus. Get it? Okay. How do I measure the distance of this point to the line? Do I measure it like that? Is that my distance? No. How do I measure it? Draw a perpendicular leg, right? Okay. So measure the distance like that. And on this line, which point is equidistant to the directrix and the focus? Which point on this line has equidistant from directrix and focus? 중간에 있는 거, the middle one, right? Yeah. That is vertex. 꼭지점, vertex. Okay, that is called vertex. So we pick a point which is equidistant from directrix to focus. So this is directrix. This is focus. And this point right there is called vertex. And we will give a coordinate for vertex as h, k. So here, fill this thing in as h, k. Okay? H, k. Fine? Okay. And if the focus is below the directrix, we will choose P. So P is this distance. P is this distance. So P is the distance. P can be positive or negative. So let me put it as absolute value of P. So far so good? Fine? Okay. So here, the points on this thing, the points on this red, they have such characteristic. That is, if I look at the distance from directrix to the point on the red line, red curve, that distance is equal to the distance from this point to the focus. I know that they don't look alike, they don't look the same, but imagine that they are the same, okay? So this is x, y. If I look at the distance from red to green, these are equal. Let's find the equation of this red curve. That red curve is called parabola. 포물선. Right. Okay. So vertex is h, k. And if the parabola opens downward, parabola is opening downward, right? In such case, we fix P as negative. P is negative. Okay? So that's how we promise. Okay, guys, give me the equation of directrix. Give me the equation of directrix. What is this point? What's the name of this point? Vertex. What's the coordinate? H, k. Okay? So this is y equal to k plus h or minus h? Minus p or plus p? Minus p. Why? P is negative. Okay? P is negative. Right. So directrix is y equal to k what? Minus p. Yes. Okay, guys, give me the coordinate of this focus. This is h, k. Vertex is h, k. Okay? So what will be the coordinate? H, k plus p, because p is minus. Okay, it's below the vertex. So focus is h, k plus p. So far so good? Okay. Now, to find the equation, this point is x, y, right? And what is the coordinate of this point? X, y. This is directrix. What was the directrix equation? Y equal to k minus p, right? So this point is x, k minus p. So the distance between these two and the distance between these two should be the same. Yeah, should be the same. Okay? So first of all, a parabola is the set of all points P in a plane that are equidistant. Equidistant. Equidistant from directrix to focus. Okay, so let's find the distance. Distance between xy and the point on the directrix is x, k minus p is equal to distance between xy and focus. Focus is h, k plus p. Does that make sense? Point to directrix. Point to focus. Okay, so let's solve this for x and y. Okay? So, how do we measure the distance between 2 points? Distance between x0, y0 and x1, y1. What is it? Square root of x1 minus x0 quantity squared plus y1 minus y0 quantity squared. So I will get square root of something here, and I will get square root of something here. So by squaring both sides, because both are positive, I can get rid of the square root. So here's what we get. X minus x squared plus k minus p minus y squared is equal to h minus x squared plus k plus p minus y squared. Does this equation make sense to you? I got rid of the square root. So this is 0, so we get k minus p minus y squared is equal to h minus x is same thing as x minus h, yeah? K plus p minus y squared. So I have p minus y there. So this is k squared plus p minus y squared minus 2k p minus y is equal to x minus h squared plus k squared plus p minus y squared plus 2k p minus y. Everyone agree? No? Am I wrong? Huh? P, 어디? 여기? K squared, it is K squared P, okay. Thank you, Jimin. Okay, what's wrong here? K minus P minus Y. Yeah, that's right. K plus P minus Y. So this is K minus 이거 얘기하는 거죠. Okay. Alright. So this k squared plus p plus y squared minus 2k p minus t plus y. Change. Okay. Yeah. That would be better. Right. Okay. So. So let's do this as k minus y minus p squared equal to x minus h squared plus k minus y plus p squared. Fine? So we get k minus y squared plus p squared minus 2p k minus y is equal to x minus h squared plus k minus y squared plus p squared plus 2pk minus y. Yes? Okay, so what cancels out? K minus y squared, p squared cancels out. Yep. So we get x minus h squared is equal to 4p k minus y. It should be y minus k. Minus. Yep. 맞죠? Okay, so this is x minus h squared plus 4 is equal to 4py minus k. Yep, that's what I wanted. Yes, thank you. What can you get out of this equation? What can you know? Tell me what you can know from this equation. You can know vertex. What else? If you know P, what can you know? Focus and directrix. Exactly. Yeah. So remember this formula, and we'll see why focus is important soon. Okay. So find the focus directrix of y equal to x squared minus 1. So again, it is x minus h squared is 4py minus k. And p is less than 0 when? When it opens downward, okay? But that thing is, it opens upward or downward? Upward. So p is positive. So P should be positive. So this opens upward, so P is positive. Remember that, okay? So we're going to change this into that form. Change. 시작. X minus 0 squared is equal to y minus 1. That's y plus 1, right? Yes? And we need 4, yep? P is positive, so what do we need? 1 over 4, exactly. Yep. So what's vertex? 0, comma, minus 1. Exactly. What's focus? 0, comma, from minus 1, we have to subtract 1/4. It's minus p, right? And what's directrix? Focus is, we have to add, what was the focus? It is h, comma, k plus p. Sorry. Yeah, so it is plus. Directrix is y equal to k minus p. So y equal to k minus p minus 5/4. This is the focus. What the focus does is the following. If you have a signal coming from this direction, then if it is a parabola, every signal gets reflected to the focus. It is written right there. So what is this? It's a skylight dish. This is a parabola. And this is focus. So every signal is reflected to the focus. So you can watch the cable. Yeah, that's the property of problem. Done. Bye. Thank you.